So we're done with the branching, and now we just need to do a couple more operation here to make this shape more interesting, because right now it's sort of fake. There's not much organic stuff going on in here. So after the tilt, we want first to apply some noise and then to do another thing. So let's duplicate or rather don't duplicate, because this time we don't want to do the conditional stuff, make it green, and this will be the noise part. This time, as we said, I don't want to operate on each 5 frame. I want the noise to be a continuous thing, so basically we will have a more organic look. So first we want to take the line for the edge. So also here we do have some control over the ramp on the edge, and I already know I want something like this. So the noise will be absent in the beginning, and then it will reach the full potential at a very early age on the branch. Then we need an angle, so float angle, and we use a float channel, so CHF angle, and also a frequency, because we are dealing with noise. So float frequency, CHF frequency. Click here, this will create the space parameter, and let's set the angle to 45 and the frequency to 1 for now. So now we want to compute the noise as a float value, so float noise. We are going to use the noise function. As input, we are going to give it just the time for now. So now we can compute the final noise, so F noise, because we need to fit this value for the angle we want. So we will fit the noise value, which is going from 0 to 1, and we will fit it by the negative angle variable and the positive angle variable. Everything multiplied by the age as usual. So multiplied by age. So basically this value is an oscillating value going from 0 to 1 based on the time. Here we are remapping by the angle and multiplying by the age. So this is basically just another angle to rotate a quaternion on. So vector for quaternion function, we want to rotate by this angle in radians, so F noise. The up vector, we want to apply this noise only on the up vector. I mean using the up vector, so the vector new direction will be the qrotate function using this quaternion, and we want to update the direction vector. Let's bind it, so be at dir new dir, and if we use it as it is right now, we should already see some effect. As you can see, we introduced some noise, and this is way too much. We need to tweak this parameter. Also, we need to use this parameter, because right now we are just feeding the time. We want to add the frequency we created, and we want to set it to something like 4. So it will be way more slower. And also, and this part is sort of live, because I realized in my original setup I did have something to randomize the angle here, but it wasn't really working, so this part is sort of improvised. Basically, I want to use the ID value to get some random value for this noise angle. And the problem is the ID right now is a string value, and it does this branch. I mean, it's fine that it is a string, but we need to get rid of this word at the beginning. So here, let's just say that the ID will be equal to the I2A ptnum. So it will start with a number, and the append should work the same as before, but we should only have numbers on the ID. And this should make any difference for the add point. So this is good. And now we can use basically this sequence of number to get some random value. So I just found this random s-hash function index that apparently takes a string and return a random integer if the string is different, of course. So technically this should work also with the branch word before the name, but I will leave it trimmed because my supposition is that longer is the string that we give it and larger will be the value that we have in return. So let's keep it as a shorter string without the word branch before it. So is random hash, so let's copy this. And before the noise, let's compute this random value. So let's call it rand. We will use this function and we want to use the s at id as seed. And we can quickly test if it's working. Let's bind it, or rather let's make it as an integer attribute, variable and attribute, so it will cap some value. It will be lighter in theory. So here rand is equal to rand. Let's see if something is happening. Rand, and let's go outside the solver. Yeah, we do have some random value, so we can use it here on the noise. Let's delete this stuff. This actually needs to be a multiplication here over the frequency, and then we want to add the random factor. So if everything is correct, we should have some nice result, at least for the noise part, but something is not working with the direction, and I believe what it is because we are not carrying over the birth attribute on the trail, so basically all points are tilting at the same time. We should fix it right now, so copy this line. Let's set also the birth attribute from the current birth attribute, so get birth, and this should solve the issue, and yes, it is. Now we don't have those flattening happening because now the branch will start with an age of 0 and they will have their proper tilting over their proper age. And now we need to add the final component to the direction, which basically is a, let's call it a force, that will push the branch growing toward the open areas, which is actually another simplification of a real botanical law. Branch tends to grow where they have less competition for gaining light. So here let's copy the, let's say, the tilt. We need the condition this time. Place it after the noise and we will call this away. And for this away vector, it will be fairly simple. Let's say we have this point growing in this direction. What we want to do is to check a certain distance. Under this certain distance, we are going to check if there are any points on other branch under the distance. And if that's the case, let's say this point we will reach that threshold distance, we want to calculate a vector which will point in the opposite direction compared to that point. And we're going to do a lerp between the original direction and this new distance. So it will be something like that. So basically the point will slowly start moving away whenever it finds a point under a certain distance. So back into the solver, this is the away angle. We copied the tilt, I believe. We want to delete everything inside the condition and also all of this stuff. We just want to leave the age ramp because we need it as usual, and we want to set it to something like this. Basically the away calculation won't take any effect in the beginning, so we won't have to deal with the trunk. And we want to tie the distance to look inside of to the mass. So let's create another float variable. This will be the distance, and we will use the mass, maybe not all the mass, let's say divided by 1.2, so roughly 80% of the mass. And inside the condition, we want to use this function, the near point. So we are basically looking for the near point within a certain distance. And we want to use this last variation because we can also specify a group to filter the search of the point. So we can basically say look on all the point except your branch, because otherwise it will be always the nearest point, or almost always. And as you can see, this is a string, so basically we need to compute some string variable which say all the ID except your own. So after the condition, let's create a string variable, let's call it group, and we want to write inside quote at ID exclamation mark equal close quote plus s at ID. Basically, this is the string version of saying like inside here at ID different than s at ID. Doing it for a string variable, we need to do this inside quote because we need to concatenate all of this string. So we need to write it this way. And this was on the moving group. So this is the group name, and also initialize a vector called away without any value. This will be filled with the vector pointing away for the point we find. Then we need to create an integer variable to store the point when we find it. So int near pt. We will use this near point function. So geometry 0. The group name is group. And we want to check from the current position over the distance we decided up here. Now, the near point function, as you may read here, it returns -1 when it doesn't find any points. So we can filter this calculation now, because when the result is -1, we are not under this distance, basically. So we are good to go with our current direction. But whenever, so if the near pt is different without quotes than -1, it means we found a point under the distance. So in this case, we want to update our away vector. So, and basically we want to normalize the subtraction from the current position to the position of the point we found. So let's also create a vector variable here for the position. So near pos, it will be equal to point, geometry 0, attribute position, and the point number is the near pt. So here at position minus near pos. And then there's an extra exclamation mark here. And then we need to update the actual vector. So be at dir, and we said we want a halfway between the current direction and the opposite to the nearest point. So we're going to lerp the current direction, so be at dir, with the new created away vector, and halfway, so let's say 0.5, but we want to also multiply this for the age. So at the beginning of the lerping, when the age is very low, there won't be any modification to the direction. So let's close the condition and close also the outer one, or rather is already closed. And let's see, of course there's an error, it needs a semicolon here, and it should already work, honestly. We also want to delete these parameters here, we don't need those. So no angle. And now we should see the branches spreading more, way more than before. As you can see, the calculation got slower because the near point function is not really light, but it works fine. I mean, we tweaked the shape a lot, and actually I believe we done within the tree solver. This is basically our full solver. So if we template the trunk line, we do have something like this. Maybe the only small change I want to make is actually on the various brangle. I want to include the first frame in the conditions. So greater or equal, and also for these other guys down here. This one is for the tilt. The noise was a continuous one. Then for the away we want to include. and also for the fix up and everything else. Not for the move, we want to stay still on the first frame, but let's check the branching. It's fine. On the trail, we also want to set this to equal. And I believe that that was also the reason we were missing this initial line from the trunk to the start of the branch.